Look at the scoring problem. There is a large pile of socks that must be paired by color. Given an array of integers representing the color of each sock, determine how many pair of socks with matching colors there are. Okay, when n is equal to 7, here n is the number of socks, and there is an array which is 1 2 1 2 1 3 2. 1 2 1 2 1 3 2. Okay, each distinct number represents one color. Okay, so each distinct number represents a particular color. What the question demands from you is to find out the pairs of socks with matching colors. How many pairs of socks with matching colors are there? That's what we have to find out. It means, in this case, what is the result? This and this, it makes one pair. This two and this two makes another pair. And these elements don't have any pairs. Okay, how many pairs are there? One pair, and this is another pair. Okay, so there are two pairs in this example. So you have to write a code to find out how many number of pairs of socks are there. What it says, there is one pair of color 1 and one of color 2, and there are 3 odd socks here. What are those? These are 1, 3 and 2, right? The number of pairs is, so the number of pairs is 2. Now there is going to be a function which is a sock merchant function. Okay, in the sock merchant function we have two parameters, an integer variable n and a integer array. The integer variable n, as you can see, this is the n, that is the number of socks. It is an integer array. So each number in the integer array represents one sock. So, represents one color. So how many colors are there? 3 colors are there, because every distinct number represents a particular color. Okay. These are the constants. The value of n has to be is between 1 and 100. Okay. So the value of n here is 9. This is the array. So how many pairs are there? As you can see, this 10 matches with this 10. Okay. Then this 20 and this 20 get matched. Now for this 10, you cannot, for this 10 also you find this 10. For this 30, you cannot find any other 30. For this 50, you cannot find any. For this 30, you don't find any other 30. For this 50, you don't find any other 50. And for this 20, you don't find any other 20. So how many match are there? This 20 and this 20 makes one pair. Then this 10 and this 10 makes another pair of socks. This 10 and this 10 makes another pair of socks. So number of pairs is equal to 3. As you can look at the explanation, there is 2 matches of 10. Okay, 10 represents one color. Let's say 10 represents green color. As you can see here, 10 represents green color. So there are 2 pairs of socks of green color. There is one pair of sock of blue color, which is represented by 20 here, and there is only one sock of a blue color. It does not get another. It does not get a wife. It does not get its pair. And similarly, this 50 and this 30, they don't get another pair for themselves. Of course, it looks like that 50 and 30 are of the same color. So we interpreting that because at 10 it is blue, it is green color, so I just interpreted it that okay, so that 10 is representing green color. So maybe that is not the convention that is followed here. But actually 50 represents one particular color and 30 represents one particular color, and they don't find a pair for themselves. So how many pairs are there in this problem also? There are 3 pairs. As you can see, the output is 3. So this is your function that you have to write. This is the function that you have to write. If you don't understand what is going on here, wait for it, you will cover it in the later videos. So let me explain first the logic how you are going to do it. Let's say I start from I is equal to 0, okay, I less than n, I plus plus. In my for loop, what I am going to do is I am going to take for every element and find it out that whether that element has a pair or not. Starting from I is equal to 0, I will iterate over the array, and while iterating I am also going to increase my another variable that I will take, which is number of pairs. So while I am iterating through the array, I am trying to find the pair for the current ith value. So when I is equal to 0, what is ARR 0? It is equal to 1. Okay. So for every ith value, I am going to iterate over rest of the array. So for every ith value, I am going to iterate over rest of the array. Right? And I am going to look whether the two matches or not. So this is the outer for loop, right? So for every I, so when I is equal to 0, when I am here, I am going to check through the rest of the elements. So I am going to iterate j from 1 to n, which is in this case equals to 7. So I am going to iterate till 1 to n minus 1 obviously. Okay, so 1 to n minus 1. Presently I is 0. I am going to check for this 1. Do you get any other match? Okay, and the moment you get a match, so I will get a match. What are the indices? Let me write the indices for these. So this is index 0, index 1, index 2, index 3, index 4, index 5, index 6. For I is equal to 0, in the outer loop, I am iterating j from 1 to n minus 1. Okay. Similarly, when I will be 1, then when I will be equal to 1, then I will iterate over the rest of the array from j is equal to 2 to 6. Okay. So for I is equal to 0, j will move from 1 to n minus 1. And in the way, the moment you get the first match, means you got a pair for I is equal to 0. So here you get the first match. So you get a first match for I is equal to 0 and j is equal to 2. So the first pair of indices which makes a pair, are 0 and 2. Okay, this makes a pair for 1 and 1. Right? The moment I get a match, I will break from the loop I will break from the loop, right? So what I'm going to do is, I'm going to check if ARRI is going to match with ARRJ. The moment I get a match, I will increase my number of pairs by 1. Number of pairs plus equal to 1. Okay. And I should look to break from the loop. Means, now I should move to second value of I. I should not look for another match for this I value because I have already got a match. Because I have already got a match. Any index is going to be involved in a pair only with one another sock. If index 0 is involved in a pair with index 2, then you should break. Don't confuse yourself by thinking that if I still go further, I will make another pair 0 and 4. That is a faulty reasoning. Okay, that's a faulty reasoning. Just think about this. Think about this. If you have three socks, okay, of same color, you are actually having only one pair, right? So if you have 1, 2 and 3 ones, you are going to get only one pair. Either 2 or 4 you will get as a pair, or 0 or 2 you will get as a pair. In my code, I am starting I from 0 and I am starting j from I plus 1. So it happens that I am getting 0 and 2 as a pair. If I change my code a little bit, let's say I will keep my outermost loop as same as this, but I vary my j not from I plus 1 to n, but from n to I plus 1, then I will get a pair 0 and 4. I will get 0 and 4 as a pair and I will break there. Okay. So whatever the construct for the nested for loop, you can check. The indices for the indices involving in a pair may change, but effectively the number of pairs will be the same, right? Okay. So should I now just end this for loop and will this give the result? No, it is an incomplete solution. In fact, it will get the wrong result because it is incomplete right now. You have to look at other situations. What is that? And that is this. I have breaked it and saved my I is equal to 0 to not give faulty pairs with 0 and 4. If I could have continued, if I would have not break from this inner for loop using this break, the statement, then I would have matched the one at 0th index and 4th index also, right? Very good. Now think about this. I will increment from 0. So I for 0 we have done. It will go to 1. Then I will become 1. And for when I is 1, j will go from 2 to n. And we will see if there is any match or not. Same process will go through. When I will become 2, what do you think? Should we go from j is equal to 3 to n to check if there is any match or not? The answer is no. Then you find a match for 0 and 2 and you break from this inner loop and not integrate j further to get another match. In a similar manner, it means what? It means 2 has also got its match with 0. Now, when I is 2, you should not be going in this loop. You should not be going in this loop to check for any match because 2 has already been in a match. So what I should be doing is I should make sure that the elements that are already been involved in any kind of pairing they should not go through this for loop. Okay, the indices that has already formed a pair, they should not further go through these logics. They should not go further through this for loop. We have to get into a for loop. How are you going to stop from implementing this pair? Because it will match. The value at indices 2 and value at indices 4 is 1. So it is going to match. So it is going to increase the pair. So how are you going to stop it? And how are you going to not stop it when there is match with indices 1 and indices 2? What we can do here, we can change the condition in this if block. We can change the condition in this if block in such a way that it incorporates this situation also. What I mean to say that it not only checks if the two elements are equal, at the same time it should check whether the indices, whether I or whether J, they have already made a pair or not, right? So you can say that this should match, ARR I should match with ARR J, and the condition that the indices are not already been paired into. Okay? This is possible. How are you going to give the logic to get this already paired? What you should do to get this already paired? Before checking whether there is a match or not, you will take a Boolean variable named as already paired and keep it as false. Okay, so initialize it as false. Already paired is equal to false. Means I have to figure out the value of already paired before getting to this if condition. So how are you going to check that if the indices are already paired or not? Keeping a record of indices that are already got involved in the pairing. If you keep a record of indices that already got involved in pairing, then this will help. Then you will just check if I or J matches with, means if I or J is among those indices that are already got into the pair or not. If that is the case, then we will make already paired to be true. I hope you get it. If you are not getting it, let me do it and show you what I am saying. So what I am saying, I think the codes, if you think that the code is becoming complex, then let me tell you, I am doing it because I want to solve this problem on the go. Means I want to solve this problem while iterating on the array itself. The other way means the first thing that could come in someone's mind is this, that okay, we have to find the number of pairs. Okay, means if there are, let's say, 3 pairs, it means there's going to be at least 6 socks. If there's pairs available for every sock, then if there are 3 pairs, it's known that there are 3 pairs, then there's going to be 6 socks, right? And if there are, let's say, 5 pairs, then there's going to be at least 10 socks. And maybe some extra socks are there which is not paired with here, which are odd. Okay, this is possible. If your number of socks is n, then what is the maximum value of your number of pairs can get? N by 2. n by 2. It cannot get more than that, right? So what we can do is, we can add another, means this for loop, we can put this for loop under if number of pairs, because why? Because we will be updating number of pairs in our code. So I will put, you can put a condition that if number of pairs is as long as if it is less than n by 2, only then you get into this for loop. So what will happen is, maybe what will happen is, maybe by half of the array, the moment you go through half of the array only, from, let's say, if n is 7, and you go from I is equal to 1, 2, and 3, by this time itself, you get a pair for every element. Then at here only the condition becomes false, and you don't have to increase the value. Okay, so this is another way we can do, but we'll keep it aside. I'm just this came in my mind, so I just talked about it. Okay, now how are we going to make a record of the indices? What we can do is, we can have an array is pair indices. Okay. Now, what is the maximum size of this pair indices? Think about this. What is the maximum number of pairs possible? The maximum number of pairs possible for n elements is n by 2. Right? Now, if let's suppose there are n by 2 pairs, then how many indices will be there? For every pair there are 2 indices, right? So if n by 2 pairs are there, then it's going to be n indices in the most cases. So in our declaration of pair indices, I'm going to have 100 only, just like it was in the constraint here, right? If you look at the constraint, these were the constraint for my array, and it goes from 1 to 100. So in a similar manner, in pair indices also, the maximum possible, I will take it as 100. We are going to move, we will take another loop that will iterate over this pair indices array. So k is equal to 0, k less than n, k plus plus, and we will iterate over what? We will iterate over this to find out if I is equal to pair indices here, or I is equal, or j is equal to, or j equals to pair indices. Okay. In such a case, what we will do, we will change this already paired to be true. Already paired to be true. Then what will happen? Then what we will do? Okay, this will end. Now, this for loop will continue. The if condition of the for loop, this condition. Now this condition will do its job. So if, again, we should write not already paired first. We are using a logical operator here, which is and logical operator. So if you get not already paired as false, okay, then it will not even check this condition because there is AND operators here. Okay. So that is why I prefer to write not already paired first on the left side because the evaluation is going from left to right, right? So evaluation is going from left to right. So first it will check for this. If it returns false, then it does not care about what is here. The entire expression becomes false. So if not already paired, and and it means that if the indices are not already involved in pair, then and there you are getting a match, then what you should do? You should increase what? The number of pairs. Then you should increase the number of pairs by one amount. Okay. Also, you have to now update these two I and j in your pair indices array. So how are you going to update this? I'm taking this condition in the next page. Now what we have to do, you have to update this I and this j because index I and index j, they are a pair. The value at ARR index I and the value at index j, they are equal, so they make a pair. If not already paired, it is done that I and j is not a part of any pair and ARR I is equal to ARR j. You found a match, right? So it will increase number of pairs by one. And now you have to update this I and j in your pair indices, array. Now, at what should I fill here? Means at what index value in the pair index array should I update it as I? And at what index value in pair indices should I update it as j? So to get this, okay, how you will get this? You will get this using number of pairs only. Okay, for every match, you will have two indices. Very good. If an index have a match, it will not be involved in match with two other indices. It will always be involved in a match with one index. Right? Number of pairs is equal to 1. It means you got two indices. Let's say that is I and j. You got two indices. And this is your pair indices. This is your pair indices array. Right? So when your number of pairs is 1, this I you have to update here and this j you have to update here. Right? You get another match. The number of pairs now is 2. Number of pairs was 1. I and j was there. So because of this I and j, you get one match. And let's say p and q, because of indices p and q, you get another match. Now you have to put this p here and you have to put this q here in your pair indices value. So what is happening is this 0 is 2 into 1 minus 2 and this 1 is 2 into 1 minus 1, which is 2 into number of pairs minus 2 and 2 into number of pairs minus 1. 2 into number of pairs minus 1. So you will update this as I and you will update this as j. Okay. Now at the end you will return what? Number of pairs, because that is what is demanded in the question. Okay. Okay, now let's look into the fourth part. So this n is the number of socks. AR is the colors of socks. The array is shows the color of socks. And I'm initializing all the elements in pair indices to be 0. Okay. Now I will get the value of n. I will get the values in the colors of socks. Okay. I'm printing all these things so as to help us in debugging later on. So now I am starting my I from 0 to n. Now I will go my I from 0 to n. So if this is uh, in my color array, okay, which is represented as AR. So I'm going in this AR. I will iterate over this AR, right? From I is equal to 0 to I is equal to n. And before getting into this for loop, okay, so let's say for I is equal to 0, now I will move from rest, I will move to the rest of the array from j is equal to 1 to n to see if there is match or not, right? What I am doing is I am putting all of this in this if logic, in this if condition, that if the number of pairs is less than n by 2. Because I have already discussed it, and I'm saying this again, that the number of socks is n, then at most the number of pairs that you can get is n by 2. Let's say if there are 10 socks, that maximum you will have 5 pairs of socks. So the moment, let's say, if your number of socks is 10, and within the first 5 I, means for I is equal to 0 to 4 itself, you find the mesh. You find the mesh. Then for rest of the values of I, like when I will be 5 or 6, you will not even enter this for loop. You will just get, that's why I put this inside this if block. Okay. Okay. Now for every I is equal to whatever it is, I will move from j is equal to I plus 1 to n, and whether a particular I and j, whether this is a match, that's what I am going to, and I have brought a logic for that. So initially I have made already pair to be false. The assumption is that already pair is false. And then I am iterating over the pair indices array. So this K is going to be index at pair indices array, just for me to check if any of I or j is already been paired. In that case, I will make already paired to be true. Look at this. If I is equal to pair indices k or j is equal to pair indices k, then I am going to make already paired to be true. And then I don't need, once it is established that okay, this already paired is true, I don't need to iterate for the rest of the pair indices, so I am going to break. Now there is extra condition with AND operator I have added, which is pair indices k is not equal to 0. Pair indices k is not equal to 0. And why do that? Because I have already initialized pair indices. All the elements of pair indices should be 0 or okay, to be 0. Now when I is equal to 0, this condition will always be true. Okay? Because I have initialized pair indices in the very first statement. I have initialized all the elements of pair indices to be 0. Now when I is 0, when I is equal to 0, this condition is always going to give true. This will always return true. Right? That is why I have put this condition that pair indices does not have to be equal to 0 to check for this corner situation. Now, rest of the steps remains the same as already discussed. So already paired is true, break. If not already paired and here are equal to 0, then I'm going to increase the number of pairs by 1 and I'm going to update I and j in my pair indices. Okay, done. So let's grab this code. Enter the number of shots. 7. 1, 2, 1, 2, 1, 2, 1, 3, 2, and 5, 6, 7. Right. So these are all the cout for decorative purpose. Let's look at the results at the end. So what is the number of pairs that you are getting? It is 2. And what are the indices that got paired? 0 and 2 got paired and 1 and 3 got paired. And that has to happen. Left with 1. So number of pairs is 2. That has to happen because what was our array again? It was 1, 2, 1, 2, 1, 3 and 2. What are the indices to this? 0, 1, 2, 3, 4, 5, 6. Okay, so what are the number of pairs? This one and this one will got paired into 1. Okay, so 1 because of it. And then this 2 and this 2 can get paired into 1. 1 because of it. And this 1, 3 and 2 are odd ones. So number of pairs got to be equal to 2. That's what you got here. Number of pairs to be 2. First point. And what are the indices? So this pair you got through the indices 0 and 2. So you see here 0 and 2. Let me take any pen. So you see here 0 and 2. Look at the indices. So what it is saying, what are the indices? What are the indices paired? Okay, it is 0 and 2 and it is 1 and 3, right? So this 0 and this 2 is been paired into 1 and this 1 and this 3 has been paired into 1, right? So our solution is correct. Okay, so this is one method to solve it. Now let's look at another method how to solve it. Let me show you something. So what is the color of socks that we took? We took it as 1, 2, 1, 2, 1, 3 and 2. Okay. So how many distinct colors are there? It is 1 is and 2 and 3. So there are 3 distinct colors. 1, 2 and 3. And 1 is coming 3 times. And 2 is coming in 3 times. And 3 is coming just 1 time. Okay. So there are 3 socks. It means that there are 3 socks of color 1 and 3 socks of color 2. Right? But 3 socks of color 1 means 1 pair of sock of color 1 and 3 socks of color 2 means 1 pair of sock of color 2. 1 pair of sock of color 2. If I can find the frequency of each color, or if then frequency divided by 2, this is equal to the pair of socks of this color. Pair of socks of this color, right? And at last, if I am going to add this number for every distinct color, then I am going to get number of pairs, total number of pairs of socks, right? Means these are 3 distinct colors, 1, 2 and 3. If for 1 I find out the frequency of 1 by 2, Okay, for 2 I will find out plus frequency of 2 by 2, and for 3 I will find out the frequency of 3 by 2. Then I will get the number that will be the equal to number of pairs, that will be equal to number of pairs plus frequency of 2 by 2 plus frequency of 3 by 2. This is going to be frequency of 1 by 2 is equal to because 1 is coming 3 times, so 3 by 2 plus 3 by 2 plus 1 by 2, which is equal to 1 plus 1 plus 0, that is equal to 2. So this is another way to solve this problem. Okay, so let's solve this problem using this method.